And so, quick rundown of what we talked about last lecture. We're talking about class definitions. I'm going to go through these really quickly. So we talked about that. Okay. So we were making a ticket machine. Woohoo! And our design was we were going to have two classes, and we're not actually going to get around to finishing those two classes, but we would have had two classes in this had we gotten to completion. We were choosing meaningful names for them, and their class names, so they start with a capital letter and their nouns. We had a bunch of actions for our ticket machine, which are going to become our methods, and we had a state for our ticket machine, which becomes our fields. We did the same for tickets. We looked at how to define a class and the syntax for doing that. And those of you who come in late, you've missed the best bit already. And that's what defining a class is going to look like, and all the bits of defining a class. We talked about those parts. We talked about having fields, and fields have access modifier, type, and name, and a semicolon. We talked about fields being variables, and we had some style rules for variables. And I told a little bit about access modifiers, public and private, but I said we weren't going to worry about that too much now, so we won't worry about that now. We talked about comments, and somebody asked me after class, when do you use which kind of comment? It's really up to you. Normally what tends to happen is when you're putting comment, normally a good style is to document, to put a comment at the top of your class describing the class, and to put a comment at the beginning before each method describing what that method is for. Usually those comments are multi-line comments, and so they use the blue multi-line commenting format. Anything that's just a single line elsewhere in your code can just be a single line comment. Sometimes you'll make multi-line comments out of the single line comment thing. It doesn't really matter. I don't give a damn. Good commenting is better than exactly choosing which style of commenting you use. Like I said, comments are there to explain your code rather than just repeat what it says, and there's some examples. We looked at constructors, which are there to create new objects and initialize the fields on that object. And so the fields, our fields on the ticket machine, there are two fields we were dealing with, which is the balance and the price. And so the balance is initially 0, the constructor initializes that to 0. But the price is provided as a parameter to the constructor. And so because we might create different ticket machines with different prices, and so each time we create a ticket machine, we provide the price the starting price as a parameter. And you can have a look at the source code for that. That's the syntax of a constructor, another access modifier, name of the class, parameters, and then the body and braces. And we talked about parameters. Parameters are also variables. They have, like any other variable, they have a type. They're a way of storing data. And we'll talk a little bit more about parameters and fields today. The last thing we got onto was about this idea of assignment. And I know you were all starting to pack up your desks, so I'm going to go over assignment again, because I felt that you probably weren't paying attention last time because you all wanted to leave. So we'll start here. So the most common thing you'll be doing in your code is assignment, is putting values into variables. So I might actually, because of the variable idea, I haven't got a slide for this, but the idea of a variable is sometimes a bit tricky for people. But it's really all it is we have a name and there's a box, right? And we put something in that box. So when we say price equals 150, we're putting 150 in that box, right? If we then go on to say price equals 200, whatever's in the box is thrown away, and we override it with 200, right? So a variable is just a named box that we put things in. It has two things. It has a name and it also has a type. So in this case, this is an int, and so that box contains a number. If the box was if instead we had a thing called, for example, name, and that's a string, then what goes in there is a string, like Malcolm, right? And so name is a box that contains a string, price is a box that contains a number. Sometimes people ask me what happens to the thing in the box when you override it. It just gets forgotten, right? You don't take the thing out of the box and put it somewhere else. It just goes away. Because it's like Well, it's like a box on a whiteboard, right? It's not a physical box, it's a box like this where I just rub that out and put a different number in there. Okay? So that's all a variable is. It's a box with a name. And the nice thing is that we can use that name then to refer to that box in different places in our code, so we don't have to worry about it. What's really going on is that data is being stored somewhere in the computer's memory. But we don't need to worry about that because Java is a high-level programming language, so you don't need to worry about all the stuff that's going on under the hood. Later on, you might want to learn some stuff about what Java's actually doing when you stick a number in a variable, but we're just not going to worry about that. A variable is just a box that we're sticking things in. So an assignment then, an assignment statement is the left-hand side we name a variable. I'm going to wander a little bit just to annoy Morgan. Left-hand side we name a variable. It has to be some variable that we've already defined, so a field or a parameter as far as we know so far. And the right-hand side we have some value that we want to stick in that variable. So if we say balance equals 0, then this is taking the value 0 and putting it into balance. Now the value on the right hand side, so we can do this as many times as we want, and each time we throw out what was there before and stick a new value in. So if we have this code, price equals 100, price equals 200, then we stick 100 into price, and then we throw it away and stick 200 into price. And so now the variable price will contain 200. Excuse me, I have a sore throat today, so I might be coughing a little bit. Where did I put my... Oh, nuts. Oh well. Okay, so this was where we were up to. The other thing I said was that you don't just have to... the value part of an assignment statement doesn't just have to be a number or what we call a literal value. So 100 there is what we call a literal value. It's a value that's unadorned. It doesn't come from anywhere else. It's just the number 100. But that value can be anything we want, and it can come from other. We can compute that value from other places. So one of the things we can do is that we can say price equals balance. This takes the number that's currently in balance and sticks it into price. So if we had drawing boxes again, we have here balance is a box, it's an int, and we have here price. It's another box, and it's also an int. And initially, when we create them, they're both 0, because Java always initializes variables to 0 when you create them. But then we say balance equals 100, and so now 100, we write 100 in that box. And we now say price equals balance. We look at what's in the box marked balance, it's 100, and so we write 100 into the box marked price. It's that easy, right? It's just copying information from one box to another box. Later on, we'll talk about how to do. You can do more than that. You can actually use, formulae to calculate new values to stick in there. But we won't do that yet. But the most important rule of assignment is that the type of stuff you have on the left-hand side has to be the same as the type of stuff you have on the right-hand side, right? So if, for example, I don't think I've got a slide of this, so let me draw it here. If we have what we had before, we have name. It's a string, and it contains the string mal. Right, now if we say price equals name, now we have a problem, right? Because we're trying to take a string and stick it in a box that contains a number. That's not allowed. Java will complain. And Java is smart enough when you... because every variable you have has this type associated with it, when you try to compile this, Java will look at that and say, well, the thing on the left is an int, and the thing on the right is a string. We can't put a string into an int, and it'll tell you that your code has an error in it. So this is true even if something like this might be the string 100, right? This string 100 is different from this number 100. The string 100 is the characters 100. The number 100 is the number itself. And Java doesn't know that these mean the same thing in some sense. And there's a good reason why, because they might not mean the same thing. I mean, there's lots of different ways you could interpret that string. And so Java doesn't automatically convert these for you. If you want to do that, you have to go and write some code which actually reads these characters and works out what number that you've written there. And that's, well, there's built-in code in the libraries in order to allow you to do that, but writing it is a little bit trickier than you'd think. Is there enough light on the board, Morgan, for you to be able to see that? Cool, okay. So the general rule is that the type on the left has to be the same as the type on the right. Later on we'll get into something called polymorphism, which actually is an exception to this rule, and we'll have a slightly more sophisticated version of this rule. And we'll also get into typecasting. Oh god. Oh, well. Anyway, later on you'll find out that I'm lying to you, but right now it's a convenient lie, okay? It's like your teachers have been doing forever. They told you that atoms were made up of electrons and neutrons and protons, and then later on you found out that they were lying to you and that they're actually made up of, well, I don't know if you got that far. I love the way chemistry teachers lie to you successively, and then anyway, I tell you more and more sophisticated versions of more and more sophisticated lies, really, because they just don't want to tell you the whole truth. And then you laugh at those naive people who think that atoms are like bowling balls. Anyway, that's just me. I'm rabbiting on. Let's get back to programming. Okay, so that's the way we assign values to variables. And if we look at the constructor that we wrote, so we wrote a constructor for our ticket machine. It has ticket price as a parameter, and it does two assignments. One is to set the balance to 0. The other one is to set the price field to be equal to the value in the ticket price parameter. Right. So we've taken a variable, one variable, which is the ticket price parameter, and we've taken the value out of that. Well, we've copied the value out of that and stuck that value copied it into the price variable. The reason, we'll talk a little bit later about the idea of scope, which will explain why we need to copy from the parameter into the field. But the idea in general is the field hangs around longer than the parameter, and we need that value to hang around, and so we stick it in a field. I also told you that Java automatically initializes things to 0. So really this line here is redundant, right? Balance will be 0 even if we left that line out. But it's always good practice to initialize things explicitly. Cool. If it's for me, tell them I'm in a lecture and I can't speak now because that would be rude. Okay, cool. So it's always a good idea to initialize your values explicitly, because anything that's an unstated assumption in your code is easily mistaken, essentially. So it's better to make these things explicit rather than have them implicit and have someone make the wrong assumption about it. Later on, we'll find that some variables always need to be initialized. So it's just a good idea to get into the practice of initializing all your variables. So that's our ticket machine constructor. Now that we have a ticket machine, we want to do something with it. Right? So what I'm going to do is write the add money method. So the syntax for a method is very much like the syntax for a constructor, with one major difference. So we'll do this. Oops. It's generally good practice, I find. One of the things you tend to lose track of in programming is how many parentheses you've opened and closed. And you've got to always make sure they balance so that every one you've opened, every left parenthesis, you've got a right parenthesis for. I find it's a good practice if you always write them in pairs. Is that a question?
Yeah. With the ticket machine, and all that is kind of like a box in our window, right? You can add the ticket machine object.
Yes, so this is the class, and it'll allow you to create ticket machine objects from it. Yep, right.
And then that's like the right control.
So if let me show you, let's go back to BlueJ and compile this, even with that all on its own. So we've got the class. The constructor we wrote is here, right? So that constructor that you just saw there is this one here. The same thing, right? So when I run that, I'm running the code that I wrote yesterday or the other day before. And so I give it a number, which is that parameter, and there we go, we've now got a ticket machine. Okay, so now if I get rid of that. Oh, there we go. Now if I click on this ticket machine, that's the method that I just added, right? So I just added an add money method, and it turns up there. So, because constructor, the methods are defined on an individual object, but obviously the constructor has to be defined before you, because the constructor makes the object, the constructor isn't part of an object, right? The constructor is the thing that builds the object in the first place. So the constructor is on the class, but the methods are on the object. So we go back here. What I've done, okay, so now we're having a method called add money. Now we have to tell it how much money we want it to add. So that's going to be a parameter. Anything that is the input to a method is a parameter. So we say int amount. Amount is the name of the parameter. Int tells us that that parameter has to be a number. So, and we're going to add a comment here in good style, which says add an amount of money in cents to the balance. Yeah? So that comment explains our method. Okay. So there we have a method. At the moment that method will do nothing. But that's the general syntax for defining a method. So what we want the add money method to do is to add the amount that we've passed in as a parameter to the balance that we're tracking so far, right? So we need to do an assignment statement which says that the balance is equal to, now the new value of the balance is the old value of the balance plus the amount we've added in. So if we currently have 100 cents and we add 50 cents, then the new value is 100 plus 50, it's 150 cents, right? So the new value of balance is the old value of balance, if I can spell it properly, plus the amount that we've got. And that's an assignment statement. And because it's the end of a statement, we put a semicolon. The end of every statement, we put a semicolon. Okay, so that might look a little bit weird because it kind of says balance is equal to balance plus a certain amount. But don't think of this as saying that these two things are equal. Think of this as an assignment, computing this value and sticking it into this box, right? So in terms of what we were doing here, we have this box called marked balance. We have this box marked amount. That one has 100. That one has 50. Okay. So now, where did I just put that thing? Now what we do is say, okay, take the value out of balance, that's 50. Take the value out of amount, that's 100. Add them together, that's 150. And then we stick that value back in there and make that 150. So that's what that assignment statement is doing. Okay? So now if we save that, go away. Oh, this is stripy, so we need to compile it. Okay. Now if we create a new ticket machine, and we'll give it a price of 150. Now if we inspect the ticket machine that we've just got, okay, our price is 150 and our balance is initialized to 0, which is correct. If we now, let's leave that there. If we now run the add money method, and let's add 100, the balance has now gone up to 100, right? It's very exciting. If we add another 50, the balance is now 150. Interestingly enough, if we add negative 50, the balance goes down to 100, right? Because it makes sense. Adding negative 50 to 150 is 100. Cool. And we can do that as many times as we like. It can keep us amused for hours. So generally the syntax for adding a method looks like this. We have, again, an access modifier. Usually your methods will be public, or at least for the time being. Methods are probably the most likely one to have public or private. Sometimes you want your methods to be public and sometimes you want them to be private, but we'll find that out later. You have a type, which is a return type, which I'll deal with in a second. You have a name. That name can be anything you like. And we'll talk about the style of that name. You have parameters, and the parameters, each of the parameters has a type and a name, and then there's a comma between each parameter. And so we've got parameter 1, int parameter 1, comma, int parameter 2, and they go in the round parentheses. And then in the curly brackets, we're missing a box, there we go, braces. Within the curly braces, we have the method body, which tells us what the instructions that we run when we do the method. So what happens when we run a method? Actually, where are we up to? Oh, okay. Let me deal with this and then we'll do that. So, like I said, the syntax for methods and constructors is very similar. Right? In fact, deliberately so, because they do very similar kinds of things in the end. The big differences are the name of a constructor is the same as the class name. So a ticket machine, the ticket machine constructor has the name ticket machine, and it has to be exactly the same with the same capitalization and everything. If you made this a lowercase ticket machine, it wouldn't work because it's not the same as the capital uppercase ticket machine that we've named the class. Java is fussy about case, so you've got to get used to that. Methods can have any name you want. It's standard to name a method with a lowercase letter, but you don't have to name a method with a lowercase letter, but it's good style. So I encourage you to do that all the time. The other major difference is a constructor has no return type, so it's just public ticket machine. Whereas a method has this thing that I said is a return type in between the public and the name of the method, and it can either be a type like int or it can be the word void, and I'll explain what that means in a minute. But otherwise, methods and constructors are almost the same in the way they work. Okay, a method body then is a sequence of instructions, and those instructions are executed in order. So this is where we start to get down to talking about exactly telling the computer what to do. Up until now, we've been setting up these data structures and creating objects in our world, but we haven't actually given the computer anything to do yet. Now in the methods, each method contains a list of instructions, and those instructions or statements is what we usually call them. And every statement ends in a semicolon. So, well, with some exceptions, but usually every statement ends in a semicolon. Those statements are then executed in order. So it's like going back to our pancakes recipe. It's a list of instructions that you start at the top and you execute them all the way down to the bottom. We've only seen one kind of statement so far, and that's assignment. So every assignment is a statement. And we'll see more as we go. So when we call, where are we up to? Oh, okay. Now let's actually do this over here. When we call a method, so what we do, or in fact when we call either a method or a constructor, what we do is we pass a value into this parameter, and then we start executing the instructions in the body of that method, and we execute them from the top down. When we get to the bottom of the method, we finish that method, we go back and return and do whatever we were doing before we called the method. So a method just basically starts at the top, runs until it hits the bottom and goes back. Now that's not it. There are some times where you can return early. We'll get onto that in a minute. But usually your methods will start at the top, keep going down the list until they get to the end, and then they'll stop. Right? Very simple, just like following a recipe or anything like that, following a list of instructions. Okay, so I said that we could compute, I gave you the example of computing the balance, new balance based on a couple of existing values. Right? This is what we call expressions, which again is a weird name for it, but I guess it's the one that's been around forever. An expression, no, better not do that. An expression is basically a formula for calculating a value. A typical expression is 50 plus 25, you know, and the computer looks at that, works out that 50 plus 25 is 75, and then puts the value 75 into price. So anything, when a computer encounters an expression, it tries its best to find the value of that expression. And so that's an expression just using two numbers. It's not a very interesting expression. You might as well have just typed 25 in there, but maybe it's an expression you need. A more interesting expression is one like this, which says price equals price times 2. So that takes the existing value of price out of the variable, multiplies it by 2, and then sticks that value back into price. And so if price was 75 here, then price will be 150 here. So this is an expression, well, this is an expression we could have worked out by ourselves without using the computer. This isn't necessarily, if we didn't know what the value of price was, this will double the value of price no matter what it is. So it's useful to get the computer to calculate that for us. So in general, expressions are ways of computing a new value out of a bunch of existing values. And the standard kinds of things you'll see in expressions are, so this kind of thing you'll see very often, like we just did, balance equals balance plus money. In fact, this kind of expression happens so often, or this kind of combination of an assignment and an expression happens so often we have a shorthand for it, and I might use this occasionally, which is balance plus equals money. They're really just two ways of saying the same thing. Plus equals means take the old value, add whatever's on the right hand side and stick it back in. You don't need to use this. This is just a shorthand, but if you get bored of typing things as long as the thing on the top, then this can save you some space, and hopefully it's still fairly readable. Programmers always like to save on keystrokes, you know. There's only a finite number of keystrokes in the world, and if we use them all up, I don't know what will happen. But the idea is to, like I said, always keep good style. So make sure that you're that while you try to make things short as possible, don't make them any shorter. So you've seen there are expressions like plus. So the standard sort of mathematical expressions you see, we plus, minus, multiplies, divides. If you look in Appendix C of your textbook, there's a list of all the different expressions that you can use. I'm not going to go into them all in detail, but all the standard sort of mathematical operators that you would expect are in there, and a bunch of other things. There's also a bunch of operators for working on strings, for joining strings together or doing other things with them. I'll introduce a couple of them to you as we go, but I won't go into them in detail. I'll leave it up to you to read that appendix and find out what they are, or else to go on the web and search for Java expressions. I'm sure you'll find a web page that explains it if you haven't got the textbook. Okay, but the only one thing that's worth saying, which I'm so used to now that I kind of forget that non-computer people don't. Multiplication, this is an asterisk, right? The little star thing that is above the 8 key on most keyboards. Computers have been using asterisk for multiplies since the year dot, and I kind of forget that people don't necessarily know what that means. That means multiplies. Go figure. We don't use the X because that would, I don't know. Yeah, you know, that would make too much sense. We like to have our cryptic little language that you outsiders can't understand so that you think that we're doing magic. While we're on expressions, excuse me, Java has, BlueJ at least, has this thing called codepad, which lets you play around with expressions, which is kind of cool. So let me show you that. If we go up to View, Show Codepad, this little box appears down here, and then we can type in that box 10 plus 50, return, and it tells us the answer is 60, and the answer is an int, right? Which is very exciting. If we say 2 times 4, it tells us the answer is 8, and the answer is also an int. If we type hi string plus there, the answer is hi there, one word, and it's a string. Right? Cool. So plus, and this is interesting, if we say the string 2 plus the string 4, what's the answer going to be? The string 2, 4, right? Because plus on strings concatenates them together. So, like I said, the string 2 is not the number 2. They're completely different things in Java. And if you want to get the space in between hi and there, you have to say hi plus space plus there, or something like that. And that makes hi there. Oh, wonderful. You can play around that. The other thing you can... Oh, no, let's not go into that. Well, there's a lot more you can do in the codepad, and we'll deal with it as we go along. But it's just a way of essentially taking a line of code and evaluating it on the spot, which is kind of handy when you're playing around trying to see what things do. Let's make that go away. Go away. Okay. So more talking about style. I'm going to keep hammering this home. Good code is readable code. Java uses braces, those curly brackets, which, if you don't know where to find them on your keyboard, they're on the right-hand side above the square brackets next to the P. They're called braces. They're also called curly brackets and various other things. And they divide code into blocks. So you've already encountered a couple of kinds of blocks. One block is the actual object, is the class body. Another block is the method body or the constructor body. They're all blocks, and they all sit inside curly braces. Excuse me. Being computer people, we have holy wars over little tiny details, right? And so there are many common styles for where to put your braces. And if you talk to two different programmers, you'll get two completely different opinions about the right way to do this, right? But the BlueJ style guide recommends putting your braces on a new line alone. So if you look at all the examples I've done with a block somewhere, I've always put the new set of braces, ow, that hurts, the braces on a new line alone and the finishing brace on a new line alone, right? This is the style that the BlueJ recommend. Okay, there are lots of different ways of doing that. That's not my favoured style, but I'm going to go with it. So because it's better to choose like anything with style, it's better to choose something consistent rather than to mess around and do a bunch of different things. So I recommend that you do this style. Just because then I know that you're all going to do that style rather than having to, you changing around, or worse yet, you changing what you're doing all the way through your code. It just makes, because one of the important things in reading code is understanding what block you're in. Is this piece of code inside this method, or is it inside the class, or is it somewhere deeper inside a block? So the best we can is we try to lay out the code to make that obvious. And if you start messing with that, then you make your code harder to read. The other thing we do is we always indent, and no matter what style you use, you always indent code within a block. So every time you open a new set of braces, the code inside that set of braces is indented in to the right a little bit. And you open another set, and the code inside that set is indented in a little bit further and indented in a little bit further. So if you look at what I wrote, if you look at the code that I wrote before, we started the class, we put a brace on a new line, an empty line, and then everything inside that is indented by the same amount, right? All of this lines up here, lines up nicely until we get to a new brace. As soon as we got to that new brace, we indent by the same amount again, and everything inside this set of braces is indented by that much until we get to the closing brace, which sits on a line by itself, and then we go back to the old indentation level, right? And then we keep at that level until we hit another new line and we jump inside. In fact, we've done this slightly wrong. There we go. So usually it doesn't really matter how, I mean, like I said, Java doesn't care about space. This is only for readability. But usually 4 spaces is about the right amount. Just try to use the same amount wherever you use it, right? So always use, and the easy thing is if you use the BlueJ editor and you press tab, tab will automatically move you in by 4 spaces. I think it's 4 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 4 spaces. So that means that your code will line up neatly. So using tab rather than spaces is generally a good idea. Just makes your code easier to read and thus easier to understand. Right. So it doesn't affect the correctness of your program, but it affects the readability. How are we going for time? Oh, wow, okay. All right, so the debugger is the next thing I want to show you. When we're executing, when we have fairly complicated pieces, this code is fairly easy to understand, right? But when we have more complicated pieces of code, it's going to be a bit harder to understand what the code is doing just by reading it ourselves. Now, a crucial skill that you need to learn is to read code, right? Because you never, I mean, it would be stupid, you never learn to write before you can read, right? Does that make sense? You need to be able to look at this and tell me what it does. And so one of the things we're going to be doing a lot of is me giving you a body of code in your labs, and you reading it and trying to work out what it does. It's very important. It's tempting just to try to run it and see what happens, but if you do that, you might miss some of the important details about what's actually going on, because there are many different ways, depending on what input values you give, your code could do a lot of different things. And if you can't read the code and actually understand what it's doing, then you won't understand, well, you won't understand what the code's doing. Your testing will only get you so far. So you need to learn to read code. But one of the things that can help you to do that process is to watch the code actually as it executes. And the debugger gives you that ability. Yeah, I've got to tute in 15 minutes. Thank you very much. So the way to start the debugger is like this. If we open up the source and we click in this grey bar on the left-hand side, not there, it's going to complain. Okay, but if we click here, no, oh, come on, do what I want you to do. Or maybe if we don't do that, what are you doing? I said click there. Okay, that doesn't work. Okay, I lied to you. It doesn't do that. Okay, hey, that's interesting. Let me try this instead. No. Okay, so that worked before. Compile. Okay. Right. Aha. Compile your code first. So if the bar is grey, you can't click in that area. It beeps at you, and that's confusing. If the bar isn't grey, if it's white, then you can click in that area, and a little stop sign comes up. Right? That's called a breakpoint. And what this will do now is that when the code gets to that line, it will stop. Let's see if we can do this. No, we can't. Okay, so we can't do them out here because that doesn't allow it. You can only put breakpoints inside your methods or inside your constructors. I'm going to stop saying method or constructor after a while because most of the stuff is the same for both of them. So inside your method, I'm just going to call them all methods. So inside a method, you can click and a little stop sign will come up on that line. What happens now is if we go back to here and we try to run that constructor and we give it a value 100, okay, this window pops up and this is the debugger window. And this line, and here in the source code, a little arrow is pointing next to that line and that line is highlighted. Okay? So what's happened is the debugger, when we have breakpoints, the debugger kicks in and when we run the code, it gets to the breakpoint and stops. And it doesn't actually run that line, I'm pretty sure. Yeah, so that line hasn't been executed yet. It's got to that line and said, whoops, there's a breakpoint, I'm not going to do anything. And the debugger pops up. What we can now do with the debugger is this. We have a couple of different options here. I'm just going to show you the step button. If we press the step button, so what we have listed here, first of all, what it shows us, well, there's a bunch of stuff it shows us that we don't really need to worry about. But one thing it does show us is these are the instance variables. These are the fields, essentially. So at the moment, price is 0 and balance is 0. If we press step, it executes that one line of code and price is now 100. And now if we press step again, it executes the next line of code, which doesn't actually change anything, so balance is still 0. And if we press step again, the method is finished, and so the debugger exits. Right? So this is a way for you to watch your code executing, and you can watch it go through line by line and step through. This is really handy, especially when you're debugging more complicated code, because you get to see, okay, we'll get to there, oh, wait a second, that's not right. And when it does the wrong thing, you can then identify where in your code it's doing the wrong thing. So the debugger is really useful in that fashion, and I encourage you to use it, but I also encourage you not to rely on it. You should be able to read and understand code without it. And in fact, one thing I'll tell you now, in the final written exam, we will give you code on a piece of paper, and you won't have a debugger in which to run that code. You'll need to be able to look at that code and run it in your head and tell me what it does. Right? This is a crucial skill. But for the time being, try using the debugger to see what code does in order to gain that skill. But what I recommend is before each time you press step, think to yourself what you expect the debugger to do, and then press step and see whether it's done what you expected it to do. And that way you can actually begin to learn to predict these things and read the code properly. If you just click on it blindly and don't think about it, you won't learn that, okay? So there are some people who say that teaching you debugging, this sort of debugging tools at this stage is actually hampering your learning. I think it's an advantage because it's often hard to follow code in your head, but you need to learn the skill. So I'm going to just keep repeating that. Anyway, but I'm taking a lot of time, so to get through early stuff, so we can step through. Okay, so kinds of methods. So we just wrote one method. I'm going to write another method on our class because I can. So let's get rid of that breakpoint. We don't need it anymore. So one of the things that are so when I talked about accessibility modifiers, I said that we normally make fields private. If a field is private, that means that nobody else can access that information. So each object has its private information which only that object can look at. If we made that information public, then anyone else could look at it and anyone else can change it, which is generally a bad idea. So almost always our fields will be private. But the problem then is, if a field is private, there are some times when another object needs to get at that information. And so in those cases, what we do is we add accessor methods, which is another method which returns that information. So what we're going to do now is write an accessor method, which is in order to find out how much balance there is at the moment. All right, and so this is an accessor method. There we go, and we're going to give it a comment, return the current balance in cents. I guess I can keep saying that, but and so all this does is this method, when we call it, we don't need to provide any parameters. All it does is, in fact, I've made a typo there. So, in fact, if I tried to compile this now, let me just show you what happens. Aha! Can't find symbol variable balance. So it doesn't know that balance is a misspelling of balance is a misspelling of balance. It just knows that there's no variable called balance that I've defined anywhere, and so it tells me that there's an error, which is good. And the nice thing about this is it tells me that the error is on that line in exactly this spot, and so I can go and change that. And you should feel happy about that, because in my day it didn't do that. In my day it just said syntax error, and you went, yeah, can I have a little bit more detail please? And then you went groveling through your code for hours trying to find where you'd made a misspelt something once. So anyway, so we fix it, and we compile that, and it all compiles beautifully. And now what we can do, we create a ticket machine. We make the price 100 and whatever, 100. We can now have this method int getBalance. And I said before that, I don't know if we dealt with this in the first couple of lectures, but some methods return a value. I think we might have looked at that before, right? So this is a method that returns a value. This is the value is 0 because the balance is currently 0. But now if we go and add some money, we add 100, and we call getBalance, again, it now tells us that the value in that the value is 100. So this is basically accessor methods let you, where did the thing go? Accessor methods let you are ways of taking the private information and providing it to other objects, making it public in a way. Now the advantage of having an accessor method like this is that you can read the balance using this method, but you can't write to it. So you can't have somebody else just go in and change your bank balance without, they can find out your bank balance by asking the question, but they can't actually go in there and change your bank balance. You know, I found out recently, you can't stop people depositing money in your bank account. It's really strange. My flatmate moved out at the end of last year and is still paying rent every month. And I can't stop it. I went to the bank and said, can you just, tell her bank to stop giving me money? And they said, no, it's yours now. It's your money. She gave it to you. So there you go. But anyway, that's an aside that has nothing to do with what we're doing. So back here, so like I said, so Java doesn't tell the difference, but there really are sort of two basic kinds of methods that you'll be writing. Some of your methods will be accessor methods, which get information out of the class. So it's ways of finding out information about an object. Some methods are mutator methods. They actually change the object. So the add money changes the data, the state of the object of the ticket machine. It changes the balance. The get balance doesn't change anything. It just gives you some information. The add money doesn't return any information. It doesn't tell you anything. So Java doesn't actually make a formal difference between these two, but you'll tend to find you're either writing one or another. And it's generally a good idea to kind of have a good idea, well, to know which kind of thing you're writing. An accessor method returns a value. And so where we said in the syntax of a method, we had this type here before the name of the method. But that type is the type of value that thing's going to return. So if getPrice is an accessor method to tell us the price, it returns an int, because the price is an int. So that's a method that will give us an int or a number. If we had a getDestination method, that might return a string because the destination is a string. So depending on what kind of data we want to get back, we have to tell it what type the data is going to be. If we have a mutator method that doesn't return any data, then we give the type void. So void, that means there is no return type. And so if we look back at our code before, cool. Our add money is a mutator, so it has void, there's no return type. Our get balance returns an int. The last thing we'll deal with, okay, to return a value then you need to have a return statement. So a return statement just starts with the word return, and then a value after the word return. And that value is the number that you'll be sending back. So the type of the value has to be the same as the type that you said you were going to return. So if I said I'm going to return an int, after the value I am returning has to be an int. And now that value could be a number, it could be a variable, it could be any expression that I want. It just has to be a way of computing a value that I'm going to return back again. The other critical thing is the return statement is the last thing that happens in your method. If you put code after the return statement, that code won't be executed because the method gets as far as the return statement and says, whoops, return, I'm going back. All right, I've got a value and I'm sending it back. And anything that happens after that, I don't care. It's not going to do anything. So the return statement is the last thing that's executed. We're running out of time, so I'm going to finish it there. We'll talk more about variables next week. Thank you all for coming.